Let's see what the graph of the tangent function looks like. So we have y is equal to tangent of x. Let's get some ordered pairs. Now remember that the period of tangent is pi, so we only need to look from 0 to pi. So the input is x, the output is tangent of x. So starting from 0, let me grab everything from the first quadrant. So pi over 6, pi over 4, pi over 3. At the top of the circle we have pi over 2. Let me grab maybe like 3 pi over 4, and then we'll just end at pi. So this is going to be one cycle because the period of tangent is pi. Okay, so then all we need to do is find what the tangent of each of these angles is. So I'm going to refer back to my unit circle and do y divided by x. So the tangent at 0 is 0 divided by 1, or 0. Okay. At pi over 6, we have 1/2 divided by square root of 3 over 2. In other words, 1 over square root of 3, because those 2's are going to cancel, giving us square root of 3 over 3. At pi over 4, x and y are the same, so we get 1. At pi over 3, square root of 3 over 2 divided by 1/2, the 2's are going to cancel, so we're just left with square root of 3. At the top of the circle, we have a problem, because 1 divided by 0 is undefined. So let's see what that does to our graph. At 3 pi over 4, x and y are opposites of each other, so we get -1. And then at pi, we have 0 divided by -1. Okay, so to figure out what our graph is going to look like, let me get a couple approximations. So the square root of 3 divided by 3, it's about 0.6. Square root of 3, about 1.7. Okay, so let's start graphing. Let me start with my x-axis. And then I'm going to put my y-axis right down the center. So there's my 0. And then we just went over until pi. So half of that is pi over 2. Half of that is pi over 4, and then 3 pi over 4. Okay, let's mark out where 1 would be. So pi is about 3.14, so pi over 4 is about 3/4. So a little more than that. Another point we have is at 1.7, so let me mark out where 2 is. Okay, so at 0 we get 0. At pi over 6, we get about 0.6. Pi over 4, we get 1. Pi over 3, we get about 1.7. Okay, at pi over 2, we have a problem. Deal with that in just a moment. At 3 pi over 4, we get -1. And then at pi, we get 0. Okay, now the problem is that at pi over 2, we can't have a value there because it's undefined. So we're going to get really close to it but not quite touch it. In other words, that means we're going to have a vertical asymptote. Okay, so between 0 and pi over 2, we're going to get close to pi over 2, but not actually touch it. So then the same thing happens between pi over 2 and pi, it's just the reverse effect. So this is actually one cycle of tangent, but it kind of looks incomplete because what's happening on the other side. So recall that the tangent function is an odd function, which means that it's going to have origin symmetry. So I'm going to take these points that I've plotted and reflect them over the origin. So here is pi over 2. So let me mark out where -pi over 2 is. which also means there'll be a vertical asymptote there. Okay, so then taking these 4 points and reflecting them over the origin, now we can see what looks a little bit better here, one cycle of our tangent function. Okay, this is just one cycle. The other side would just keep going up. So there can be many cycles, but this is just one from 0 to pi, or now from negative pi over 2 to pi over 2. So a couple things to note. First of all, the domain is not all reals because I can't have negative pi over 2 or pi over 2. If I were to keep going, that would become 3 pi over 2, 5 pi over 2. So we can have all the reals except any odd multiple of pi over 2. So 3 pi over 2, 5 pi over 2, etc., etc., etc. So let me call that k pi over 2, where k is an integer. Okay, so all those will be vertical asymptotes if we have an odd multiple of pi over 2. And then the range, if you look at from the bottom to the top, we can have everything. So the range is all reals.